Good day to all. Welcome back to the lecture on malware analysis. So we have been seeing Unit 3 dynamic analysis, and in Unit 3 we have completed the first two topics, live malware analysis and dead malware analysis. In this session we will be seeing about the next topic, which is titled as analyzing the traces of malware, and this analysis can be done with, or it is being explored with, four different types of traces. First one is how you can get the malware data from system calls, API calls, registries, and network activities. So moving on to the lecture, analyzing the malware traces. Any kind of malware, it enables an IT team to better understand how that particular malware is going to work and where it is going to infect the system, so that they will be able to get back the original system to its place. Any kind of malware analysis focuses on identifying the behavior of the particular malware and preventing the system against the malware so that your system will not be compromised. In this analysis, we are going to mainly focus on how a malware can be identified based on analyzing your system calls that it makes to the Windows, or the API calls which the malware is going to make, registry calls, and the network activities that are being executed when that particular malware is being analyzed. Right. So moving on to the first topic, we are going to concentrate on Windows API. As you know, API stands for Application Programming Interface. An API is nothing but a tool which allows two different types of software to communicate with each other. A simple example for API is, say, consider you are able to view your weather or the climatic condition in your mobile phone. Right? There is a sensor which is being placed somewhere in the world, which is capturing the actual weather, uploading it to a server which is located somewhere in the world. Right? Your mobile has an application which is able to download the data from that server and allowing you to view the data. This is a simple example for API. So you have an application in your mobile phone. There is some other application running in the server which updates the real-time data. The API allows these two applications to communicate with each other. There are a lot of API which is available in your Windows operating system, right? And we will be seeing how to identify the trace of a malware using these API calls that a malware is going to invoke when it is being executed, right? So mainly this analysis is used to understand the interaction of the malware with the API call that it is going to create, right? In general, any kind of malicious software will commonly make use of that particular Windows API to execute various actions that are not allowed by a, or that cannot be performed by a normal user, right? The first step in analysis is dynamic analysis, where we will execute the malware in a controlled environment like a sandbox or virtual machine or simulator or emulator, as we have seen previously, and try to analyze the behavior of the particular malware. Right? And the second step is, there are a lot of tools that are available to monitor your malware analysis. A simple tool which we will be seeing is ProcMon, which is called as Process Monitor. It mainly captures the API call that are initiated by the malware during the execution of it, right? And this particular process monitor allows you to filter the result based on specific set of keywords or based on specific set of filters that are already available, which can be associated with the malware, right? By analyzing those data, if you find any suspicious activity or unusual API calls, we can be able to identify what the malware is trying to do, and we can prevent that particular malware from the system. And static analysis, as we have seen, there are tools, namely IDA Pro or Gitra, which are mainly disassemblers, or you can make use of tools like Oli Debug or Windows Debug, which are mainly debuggers to analyze the binary file of your malware. Any kind of malware can be converted into a binary file and it can be analyzed manually so that you will be able to get more amount of data, right? And there is one more concept called API hooking, which is mainly used to investigate the possibility whether API can be hooked or not, or rootkits are available when you perform an API call, right? So mainly malware make use of hooking techniques to intercept and modify the API calls that are communicated between two different softwares or two different applications that are running in your system. And behavior analysis, as we have already discussed, this particular thing focuses mainly on the behavior aspects of the malware, including what kind of processes it is creating, what are the files it is modifying, what are the network communication it is initiating, and what are the registry access or registry changes that particular malware is making in your system. So by analyzing these factors, you will be able to come to a conclusion what malware is intending to do. Right? And strings analysis, again, it is used to analyze the malware from the binary file of it. Right? So you can use a particular set of patterns checking for API names which create suspicious activity or any kind of URL which will be a suspicious thing or which will be a malicious code which is present in the binary of the malware which will be executed during the runtime. So by using this kind of analysis, you will be able to identify what the malware is trying to do. Similarly, functionality mapping. So you have a functionality, you just map out the functionality of the particular malware by understanding the working of API. Say consider I am using a API which will try to get the data from the weather server. But this particular malware is using that API to get some other data which is not at all relevant to weather from different server, right? So by using this kind of functionality mapping technique, you will be able to identify and prevent your system. So these are some techniques by which you can use Windows API analysis to identify the behavior of the malware, right? And the second one which we will be focusing is registry analysis. As you know, registry is nothing but a data or a fast memory which stores most frequently used data, and it is directly going to access the kernel, right? So by understanding the interaction of malware with the registry, we will be able to identify lot amount of data, right? And in general, malware tries to manipulate the registry for persistence or for changing the configuration or for other malicious purposes. So the first thing which we will be focusing is registry monitoring tool, which is namely process monitor, which is available for Windows, right? So this particular tool will actively use dynamic analysis for identifying any kind of key creation, modification or deletion kind of events. On registry forensics, we will be using tools like registry editor or registry ripper, which will extract the registry hives from the infected system, and you can perform the analysis in offline by using these tools, and it will try to examine the keys and the values that are being modified by the particular malware during the execution. Right. And auto stop mechanisms, where it will try to change or identify the changes that are made by the malware for that particular auto start registry, right? So there are certain functions which should be automatically started when the system is booted. So malware will try to infect those functions or change those functions location so that your system will be infected. So you can use these analysis to identify which functions have been modified, which functions have not been modified. And configurations. So some malware stores the configuration data in the registry. So you can go and verify the available registry keys or the particular values that are available in the registry so that you will be able to identify what are the encryptions or what are the addresses or what are the commands that are being stored in the malware and that are being modified simultaneously. And shellbacks or persistence analysis is mainly used to analyze the recently accessed folders or most recently accessed files which the malware may leave some traces. Similarly, persistence is like where what are the services that are being initiated by malware or accessed by malware, what are the drivers that are being used, what are the tasks that are being scheduled or that have been scheduled which are modified by the malware. These analysis can be obtained. And correlation with API activity, mostly the malware will try to modify the registry and the API calls that are being done with the registry and observe what it is being done during the dynamic process. And we will be also able to identify based on the activity how the malware got the escalated privilege to access the registry. And artifact extraction, mainly it is used to extract and analyze the registry artifacts for identifying the compromised indicators, which can be either future threats or the current threats which are being analyzed and obtained in your system due to the presence of rootkits or a vulnerability which is yet to be finalized. Right. In our next lecture, we will also see the analysis of malware based on system calls and the network traffic analysis. Right. Thank you all.